Okay, so the date on your opener says 410, but we're going to complete it today, which is 415. The directions say, find the greatest common factor of the terms in each expression. Who can tell me what a term is? Yeah, it's the numbers. So basically, this first expression has how many terms? 2. Remember, terms are separated by your operation sign. So 8C is a term, and 10 is a term. So you have 2 terms. How many terms does the second expression have? 3. And how many does the third have? 3. Good. Okay, so all you're going to do, you're basically going to ignore the addition and the subtraction sign, and you're just finding the greatest common factor of each term. So when we go to find the greatest common factor of each term, what's the first thing I have to complete? Factor tree. So what are 2 factors of 8, Daisha? Keep going, finish 8 off for me. And then go ahead and do 10. Okay, I'm going to come to the right. I'm going to write my factors out. So I have 8. We did 2 times 2 times 2. And then I write my factors out for 10, which is 2 times 5. Now, if I'm finding the greatest common factor, my next step is going to be to do what? Not necessarily pairs, because if we have 3 terms, we're not going to circle pairs. We're going to circle what they have in common, which is 2's. Do they have anything else in common? Okay, so my greatest common factor is 2, but then we need to look at variables. One term has a C. Do they both have a C, though? No. So they don't have that in common. So the greatest common factor is just the 2.
Isn't it 4C? I mean 2C?
Nope, because they don't both have the C in common. They both have to have it in common. Do you have your ID? Alex, you said you had your ID. Okay, let's take a look at this next one. So now we have 3 terms that we're going to go ahead and factor out. Let's hear from AJ. What are my factors of 32? What? No. Keep going. Okay, for 28, Alex? What? What 2 things can you multiply together to get 28? How about 2 and 14? Okay, what about for 14? Up 1, 7. Okay, and David, what about for 24?
2 and 12. For 12, 6 and 2. 6, 3 and 2.
Okay, I'm going to come to the right. I'm going to write my... How many 2's do I have for 32?
I had to run opener. That's when I was so confused.
Oh, did we...
I was like, wait. Yeah, I got that.
Well, you got a totally different opener.
Yeah, that's when I was so confused. It's like, what?
We actually figured the switches out. Yeah, we sure did. That's your switching right I was like, I am in the right class, right?
Yeah, that's
I was looking, at least you paying attention.
They were like, yeah, I know, for real. Like, I would have not cared, bro.
And he's not. Huh? It's you didn't get a paycheck. It should be in your folder.
Yeah, multiplication chart.
Huh?
Multiplication chart.
Oh, sorry. Yeah. Okay. So then for 28, I'm getting there, Mackenzie. 28, I have 2, 2, and 7. There you go. So 2 times 2 times 7. And then for 24, I ended up with 2, 2, 2, and 3. So 2 times 2 times 2 times 3. So now we have to find what all 3 of these terms have in common. So what do they all have in common here?
I got 2 sets of 2.
2 sets of 2's. Any other number in common?
Nope.
Okay, so we can drop down the greatest common factor. What's 2 times 2? 4. So you can write out 2 times 2 equals 4, or you can just simply 2 times 2 is 4. Okay? Now, we have to worry about our variables. Do they all have an A in common? Yeah, they all have an A in common. Which is the A with the smallest exponent? The 28, because it's just A to the first. So we take the variable with the smallest exponent, because that means they all have only one A in common. Do they all have a B in common? No. Nah. So they can't have a B as part of the greatest common factor. So the greatest common factor for this particular problem is 4A. Okay?
How you get 4A? All the other ones we didn't get 4A. You got 2.
Because they had a 2 in common, another 2 in common. So I took 2 times 2 to get 4.
Oh, that's what I did up there at the top.
Yeah, up here they only had one group of 2s. So, all right, backside. Not yet?
No, I really just got 2. I mean, go ahead.
Do you have your phone?
No, go ahead. I really just got 2.
Okay, you should be able to get the first one pretty fast. Yeah, I gave Alex the wrong opener. I just wanted to see if he was paying attention today. He was. Points for Alex. All right, we're doing the exact same thing here. Who knows factors of 54? Daisha. Ooh, I wouldn't have used those. I would have used, just because I didn't think of that, I was thinking of 6 and 9, which 3 and 18 totally works. And for 18?
2 and 9.
And for 9. Okay. For 45, let's have Mackenzie.
5 and 9.
And for 50, Cody.
5 and 10. 2 and 5.
Okay. I'm going to drop down here. I don't have enough room. I wrote too big here. So I'm going to have 54, 45, and 50. Remember, I don't need to worry about the operation signs for right now. So for 54, I have 2 times 3 times 3 times 3. Make sure I'm getting them all down right. 45, 3 times 3 times 5. And 2 times 2 times 5. Okay. So I did my factor trees. I wrote out all my prime numbers in order from least to greatest.
You
got 5.
Yeah, no, it's another 5. That's how it's like, wait, where you get.
So you guys were paying
I
attention.
know my point. Yeah, that's my point.
Remember, did you hear me say make sure I'm writing everything down right?
I mean, I was like, where do you get the 2 from?
So now do I have everything down right? Yeah. For Monday, you guys are on it. Okay. So once I've written all my factors out, I need to find what they all have in common. Do they all 3 share a number?
No.
Do they all 3 share a 2? Do they all 3 share a 3? What about a 5? Do they all 3 have a 5? Nope. So as Cody said, when they don't all 3 share a number, the greatest common factor will be 1, because every number shares the factor 1. Now we come and look at our variables. So I have E, E, E. Which one do I pick?
Yo, you can pick between yo. No, it's the 50. It's the 50. It's the 50.
Well, which E to the what power?
No, it's the 45. No, it's 45. It's the 45. No, it's the 50. Cause it's the 50.
You're not answering the question that I want. Listen, how do I know? Let me ask the question differently. How do I know which variable to pick? I pick the variable with the
Smallest
exponent, right? So 2 of my variables have the same exponent, right? So we just keep it e to the, what's the smallest exponent? Second, yeah. So then I look to see, do they all have an F? Yep, they sure do. So again, I pick the F with the smallest exponent. So I have F to the third. I have F by itself, which is like F to the first, and F to the second. Which one's smallest? F to the first, which I would write it just as F. So I could write my answer just like this, Or, what's another way I could write this answer? In simplest form. I could just write it as this. I could leave that 1 off and just write it as EF squared.